So I'm keeping this quite high level. I'm not really dropping into code that much in this talk because I'm trying to give an overview. If anybody's got any questions, really, let's pile in because we've got quite a lot of time for this talk. And I think this stuff is quite important to understand. So, first one. We talk about plugins and agents and plugins. Agents aren't plugins. They're self-contained subprograms. There's no central program in this system. Agents are self-contained things that talk to each other with a quite restricted set of operations they can do. EigenD is just a host. You know, just like an operating system, you run programs on it. You know, programs aren't plugins to the operating system. You know, they use sockets and things, so they don't have to implement TCP. EigenD provides the same sort of equivalence, quite low-level things. So there's no central authority in the system that an agent can go and look to for things. Talking about Al's database. The database is just a library class that uses the fundamentals to build a view of the system that it can use and that tells it when it changes. And any agent can do that. Most agents are written as plugins to EigenD. They're hosted by EigenD, but they're not really plugins in the extension of a program sense. And some are standalone, like Workbench. So they are, they're real programs that you run. They use the same libraries. They use some of the EigenD code inside to get the same sort of services. That's quite key. When people often ask us, oh, we could do this, with this view. Oh, you just have a list of all the things. There is no list. There's nowhere really to put such a list unless you go and build it. All of the communications between agents are pretty much asynchronous, network transparent. At the moment, we restrict the networking to the local box. It uses multicast underneath. The reason we've restricted it to the local box actually is because multicast doesn't work over wireless very well. If you multicast over wireless, I think 2 megabits is what you get, if you're lucky.
It's usually latent and unreliable.
Yes, and it's the underlying protocol. We are thinking sometime in the future of actually redoing it so it sits on top of OSC, which would be quite a good thing for us. It would be quite a stylized OSC. We'd be using it in our way, but it would be OSC. There's nothing. Most of the protocol isn't far off OSC. Same kind of concepts. As we'll see. So, what does EigenD do for agents? There are simple indexes. When an agent comes alive, it can advertise itself. So something like Workbench can listen to an index and get basically a list of agents. That's how Workbench finds all that stuff. Each agent...
Sorry, the index, where does that live? You were saying earlier there is no list. And this sounds like a list.
Well, the index. This is one of the EigenD primitives. When you've got an agent, it says, "Okay, broadcast myself using this name," and an agent using EigenD can just say, "Okay, subscribe me to that index," and then EigenD will call it back as things appear on that.
So it's part of the support that EigenD provides to.
Yes.
To an
So having said there is no list, there is a list. Actually.
I mean, a list of all the talkers, yes. Or that sort of thing.
When an agent comes to life, can it ask the system, give me what other agents are already here?
Yes, there are multiple indexes. There's one index which we call main, which basically is every agent. And so you can get a list of agents.
Yeah.
We use some auxiliary indexes as well. There's actually an index by which the interpreter agent advertises itself. So if an agent wants the services of the interpreter, it can quite easily find it.
Plumbing, for example. An agent
Yeah,
class.
the interpreter is a big, complicated agent that has a database much like Workbench. It introspects the whole system at all times and maintains a kind of list of all agents, what ports they have, what properties each port has. And so that's where the plumber is, because if you ask to connect that to that, the interpreter already has everything to hand. The reason we haven't put plumber in a separate agent would be it would need its own database. The database is quite a heavy thing to run, so we'd rather only have one of it, really, in the interpreter.
So the interpreter is more or less, let's say, not the manager, maybe
It's the
somehow the central piece that.
It's the closest thing we have.
information.
It's the closest thing we have to a manager, and in the past it has done some things, some extra things, because verbs, bel canto always goes through the interpreter. There were some times when we allowed them to have side effects, which we're gradually taking out. For instance, if you delete an agent, you really want to kind of go through and trim all the connections that agent might have had. The interpreter used to do that.
Okay.
But now, since you can go and directly delete an agent through Workbench, that was a bad idea, because the interpreter is no longer involved in that loop. So now we're gradually folding that stuff into the agents themselves, so that they really are more... anything the interpreter did that was centralized, we're gradually taking out. There's still a little bit of magic left in the interpreter, but not very much.
When you talk about agent creation, is the main index that allows it to figure out what its name is? So if I ask for a new scalar, it's scalar 4 or whatever.
Well, actually, you create a normal agent hosted by EigenD. You send an RPC to EigenD saying create a summer, or whatever. EigenD obviously knows what agents it's running. So is it, all right, I've already got summers 1, 2, 3. I'll call this one 4. And it loads the plugin and says you are summer 4.
Index, or is it?
Well, it loads the plugin. It says you are summer 4. The plugin basically creates itself, and then advertises itself as summer 4.
It's the indexing. Sorry, it's the fact that it's summer 4. How does it know it's?
Because EigenD's told it it's summer 4 when it creates it, just because it's got 3 other summers. It just finds a number that it hasn't got, right? So that's indexes. Each agent, logically, is really composed of a tree of very primitive variables that have some properties. Think of them as OSC ports, if you like, OSC URLs, same kind of thing. Very, very simple, and it's a numeric tree. And an agent is a whole bunch of them. The network layer that EigenD provides allows you to mirror the tree of ports from another agent and track it in real time. So when they change, you'll get notified that they change. That's how these databases in the interpreter and Workbench work. They mirror the ports, so if stuff changes, then the database gets the callbacks and notifies its host code through things like, oh, something's come, something's gone, something's added, that kind of thing.
And this is properties, so you're talking about the states of the agents, you're talking about the stuff that's flowing through the agents.
It's the persistent state of the agent. All the setup management is done through that.
Yeah.
What's recorded in the setup is the value of those trees.
Yeah.
It's a one-way flow. There's nothing in that protocol to change an agent. You can only look. And next, we come to RPC, which is how all changes are made. We used to change things in the state layer, have a set port, but it's actually easier. It's asynchronous, it's unreliable. It's easier to have a reliable RPC to do.
Jim, if you're writing an agent, and just want clarity, and you want things to be saved in the setup,
then they have to appear
they
in
have
that
to
tree.
appear in that tree.
If it ain't in that tree, it isn't saved. So agents have a network address. If you've been playing with bel canto, you've probably seen these addresses, things like bracket EigenD1. That is the underlying network address of an agent, which never changes. The agent might get renamed, but that underlying name will stay the same. So if it started as summer 1, even if you come in bel canto and call it summer 5, that address will stay summer 1. That's what we call the canonical name. And it's kind of machine independent. Theoretically, if we had the networking enabled, or if you had 2 EigenDs on one host, you could move an agent from one to the other, and it could retain the same name. If we were talking about OSC, we would need something like bonjour in the middle to translate that name into an IP address for the thing. With the multicast thing, it converts into a multicast group. So, some tools. We'll look about indexes first. Quite boring. There's a command line tool called BLS, which basically dumps an index. So we look at the main index, oh, actually I haven't.
It's down belt counter LS string.
Yes.
That's a magic sequence.
So I mean, this is using these examples are from the Pico modular synth setup. So if we do BLS, those are the agents we see. They're the main one. Notice we don't see the stuff that's inside the rig because that actually is in a different namespace. So mostly just the things that are running.
So it may sound like a stupid question, but BLS, what command line are you writing that on? Is that the Eigen command?
Oh, no, that's just a shell command line.
Right.
Does that work on Windows as well?
Actually, that was on Windows.
Okay.
Well, it was Sigwin on Windows.
So it's a separate little executable.
Yeah,
which
it's in
fires itself
it's
up
in
and then
user
looks for
PI.
EigenD and the setup within it.
Does it distribute with all the software?
Yeah,
Okay.
it's in user PI release /bin in there.
For some reason it didn't work on Windows, on Mac OS it works, but on Windows I just get no output.
Oh, well, I ran that on Windows.
On the Sigma, you're using Sigma. You might have to have
Are you
Sigma.
using
I tried it with both, I guess, but perhaps I did something wrong.
Are you using running it from a DOS box or command CMD?
One channel inside when both.
Oh,
Yeah, maybe.
okay.
But what happens if the address that he provides doesn't exist and you get nothing?
It'll wait for a while. I have elided some debug output there because I've got to fit it on the slide. If you use an index name that doesn't exist, it'll wait there. It'll basically it's waiting for advertisements to happen, and then it'll dump nothing. So you can't really tell the difference between a bad name and something that
It's
just
not
doesn't
a
have anything in
user-friendly
it.
tool, I think, is what you're
Yeah.
trying to say.
If you type on Windows and write on Mac OS.
Well, actually, I only use macOS now when I have to. I live on Windows all the time. I mean, all these tools do work on Windows.
Yeah.
It's,
So I'll try again.
yeah, it's. I can show you online. It will work.
Did you type the quote main thing? Because that's the thing. Your help output from your command line tools is non-existent as well.
Yes.
So,
Yes.
I didn't realise you had to put the main thing in, and I was running. It got nothing
Yes,
like B cat, B this, B that.
something I have to make wrong, so I just retry and
Put a request in, Jim,
Yeah.
for half an hour of your time spent writing a manual page for these little tools.
Yeah. All right.
Yeah.
Okay.
Just the one line. This
Just
is how
on
you
wiki,
invoke
Yes.
it.
what
This
you
is
do,
how you
yeah, how it
invoke
works.
it.
I believe BCAT does actually have a minus help.
But BLS doesn't.
BLS probably doesn't.
Consistent.
Yeah.
It wasn't until I saw the source code that I figured out how to use it.
Well, yeah. Most of these, did start life and as just
DevTools, yeah.
throwaway dev tools, and they never really come on. So the BLS language, we're doing the same thing here, and only the interpreters actually advertise themselves on there. But if you want to
Can you
find,
get a list of all the indexes with BLS?
no,
Oh,
there's no meta index.
Yeah,
there's no measure index, right?
That's what I expected BLS to give you. Was
Yes.
No, there's no meta index facility even.
language is one of those auxiliary lists you
Yes. In fact, I think it's the only one we use really. But there are a few, because things like Commander and stuff need to find the interpreter. I mean, Commander and Browser pretty much talk to the interpreter, so that's the only one we use. Talkers use that as well in order to find the interpreter. Back in the old days, all the talker stuff was done by the interpreter and sort of distributed through. Now talkers are self-contained again. You give them a phrase, they go off and find the interpreter, ask it to translate it for them. So obviously if you haven't got an interpreter in the thing, talkers won't be able to reevaluate their phrases.
You kind of have to have an interpreter.
Yeah. And there's no real reason to have more than one, although you should be able to. Apparently you can't, but you,
Really?
there's no, well, there weren't there problems. Someone tried creating 2 interpreters and it died horribly.
All right.
But there's no real reason you couldn't, but there's no real reason to do it either. Oh, that isn't very focused, is it? State variables. This is probably the key thing, because this is where the state appears. This is the running setup of an agent. Pretty much everything is visible in here. This is what Workbench uses to derive its model of the system. So everything that you can see through Workbench is visible through this network protocol. I'm using. Sorry, I actually changed BCAT2 to BCAT in the last release. And OpenOffice has kept spelling corrected BCAT2 to BCAT. I thought they'd got them all. So here I'm looking at an audio agent. I'm giving, you can use minus help. I'm giving it a whole bunch of arguments to because I want to dump a lot of stuff about the state variables. So here you can see we have a tree. There's dot at the top, /RW are the flags to the variables, and 1.1, it's a normal sort of dotted quad tree. They all have a value. In a lot of cases, the value is a dictionary, a key value pair dictionary. We use dictionaries quite a bit in the system as fundamental data types. In this case, the dictionary generally holds metadata about the state variable. The one at the top is the metadata for the agent itself. So we can see it's got canonical name of audio. It's going to be audio 1. The canonical name is set, and it's the default name of the agent unless it's overridden with a username. We can see that this tree doesn't have any protocols because that field's empty. It comes from the audio plugin. It has this configuration version. Things like the verbs this agent implements, they're also all in the metadata. I've elided that because it's a great big long list, and I don't want to go into it here. So other general variables. Most of these are dictionaries holding metadata. This one's a natural value. It's an actual real number in there. That's actually the 1.2 we can see is the audio input 2, and 0.0 is its default value. It's read-write, you can change it. Some of the other flags are to do with their hints to the setup manager about how this tree works. Some of them are quite simple, like read-write, read-only. They're kind of obvious. If it's read-only, the setup manager knows that it doesn't matter if it's different from what it wants. Things like list, and there are other ones called transient and stuff, are hints to the setup manager that this whole tree might change as a side effect of change of the load, which means normally the setup manager will send a diff. I'm getting ahead of myself. They're hints to the setup manager. I'll go on to the next slide. So state variables, what do they have? They have flags, as I was talking, things like read-write, whether they should be side effects and stuff. State variables, they have a value, the persistent value we see there that the setup manager saves. We generally call that the slow value or the persistent value or the slow data. It's handled in the slow threads. It's not really performant because it's generally handled by Python. There's also a state variable can have a single fast data stream, which is our performance data. That's not handled as simple values like we see there. Fast values are kept they're communicated via ring buffers, and generally the ring buffers are passed around rather than the values themselves.
So you're saying a variable can have both fast and slow data?
Yes, it can. And it can get quite confusing at times. We'll get onto that. So slow data, there's one per variable, and it's slow. Persistent, if something needs to be stored, it needs to be stored as a slow value somewhere.
Fast values are not persistent.
Now, yeah, fast values are not persistent. The setup manager completely ignores those. Those are used for things like, all of the performance streams, keyboard outputs and stuff. Generally, one stream is usually handling about 2,000 events per second. And if you look at a workbench thing and look how many wires on there, and a lot of those are handling 2,000 events per second. There are a lot of events flying around. So it needs to be quite efficient. And there are about 2 layers of short-circuiting data flow to go here, depending on a lot of agents just route data, they don't touch it. And they can route it they don't need to receive data, send it on. They can create routes through the system. So that's that bit. Then we get to ports. Ports are the things we talk about in Bel Canto. When you say audio input 1, something like that, that's a port. So they're really the visible things. You don't see state variables in Workbench. State variables are under the hood. Yeah, they're the fundamentals. And a port is actually a tree of state variables. When you look at that state variable tree, you're seeing also a tree of ports. but each port has elements to it which might be individual state variables. So all of that stuff, fast data, slow data, ports use that stuff to be implemented. Let's look at a port. So again, looking at the audio agent, looking at number 5. So we're looking at an output. It's quite simple, 2 state variables here. I don't know why I did that one. It's not a very good one. The root state variable of a port is this dictionary we looked at before. It's the metadata. It describes the port, its name, its domain, which is basically the data type of its slow data here. We're looking at a bounded int between 0 and 64. This port is actually the audio agent's. It has a port which is the number of output channels supported in here, currently set to 0. We can see it's got a protocol output, which is a hint to the plumbers and things that it can be used as an output. Looking at a different one here, Pico Manager, we're actually looking at the pressure output of the keyboard. So if you can find that with, it's called, keyboard, Pico keyboard 1 pressure output or something. Its domain, it's an anisocronous stream, which means really a stream of -1 to 1s or 0 to 1s. It's called pressure output. It's an output again. Currently, there's this thing is listening to it. There's another port being connected to this. Under here, the 254 subtree is the data, the value of the port is held in this state variable. We've got nothing at the root. But here, we've got 2 carrier channels carrying fast data. I've actually got 2 keys held down here at the moment. I've got key 5 and key 14 held down. And we're seeing the last value we saw coming out of those pressure streams.
Is there any significance to the numbering of those channels?
The 7 and 8?
7 and 8, yeah.
No, those are created as needed. Lots of things, I've taken out some blank ones there. Lots of things will have 10. And you'll see ID 5 and ID 14 are the important thing. That's the event ID. They could appear on any channel.
You can think of that as kind of pre-allocated polyphony, really. Is that right, Jim?
Yes. Well, most of the things that implement this, they have a threshold. They tend to start off with a number like 5 or 10. They'll hit something like 8. Because creating these is kind of a slow process, because it'll cascade all through the plumbing system. If anything receiving it will have to see, I've got more carrier channels, allocate more for polyphony. So typically it'll hit something like 8 or so, and it might create a few more. So they'll gradually increase as more and more events are used. You usually start off with about 10 because you've got 10 fingers.
Can I invent arbitrary ports for my specific agents, or is there a predefined
No, you can make them up as you
input
go.
and output has to be supported?
I'll get into that in a minute. Yeah, there are some rules about that. Right, anyway, so a port is really a tree of state variables. We also see there's a 255 subtree, which isn't used by the system. You can park any old junk you like in there. It will be saved by the setup manager and restored by the setup manager. But we're trying to eradicate the use of it. There's only a little bit left. In general, you can store also anything you like in the metadata keys as well. And we're trying to store stuff in there, so we probably will eradicate the 255 tree at the moment. But there are still places that use it. So, metadata. The root value of the port. So here we can see the full metadata of, let's say, the scale manager. So there's its canonical name. It's called Scale Manager 1, and there are various key values, most of them quite obvious. C version is the configuration version. When you make an incompatible change, you need to change that version, and then that can hook in upgrade code, which can tweak a state to let a later version, upgrade an old state.
So that been reset to 1 for 2.0?
We reset it to 1.
Because you've broken backwards compatibility.
Yes. Yeah, and we pulled out all of the code. These are the schemas of the various verbs that it implements. So these are where the bel canto verbs come from. The various bits in there are generally descriptions of the arguments that it takes and kind of rules about what kind of stuff.
So is this metadata really hold in the instance because it's called scale manager 1 here, or is it in the type? Because all the data in the
it's in the instance.
Okay.
You can set this. I mean, a port. When you get to the actual Python class that implements a port, you can have your own metadata. You can have different ports of the same class might have different metadata. If someone renames the port, the metadata will get changed.
So I could even add verbs at runtime to a specific instance of the scale manager.
The system's actually built at runtime. When an agent gets instantiated, it actually tends to create a port and then add the verbs in its constructor. You'll notice if you scan the code, we'll have adverb to, adverb, 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 adverb. It's all completely dynamic. Any of this stuff can change at any time. None of this stuff is fixed. That can make writing a client that looks at this stuff quite tricky, because you can look at an agent, but it might not be the same 2 seconds later. You need to track changes, and you need to be aware that stuff can change. Trees can change. The number of things can change. The number of children can change. The whole system can change at any time. And lots of agents use different kinds of, they use metadata to store some of their internal setup. It's a convenient place to put it. So you can put your own things in. There's one quite important metadata field, which is protocols, which is just a list of words. And it flags, every port has certain basic behavior. It supports verbs, it supports RPCs to change its name, to connect it to things, that kind of stuff. But some support special extra behavior, and you flag that with a protocol. Some flags are used just as tags, like no stage, meaning don't show this port in stage, because it's completely uninteresting or something. Some are flags to the plumber, like input and output. Whether the plumber should treat this as an input or an output. Rev connect means this is usually connected in reverse. When you connect a keyboard to a key group, there are lots of streams going forward, but the plumber looks for reverse tagged connections, which are the lights, and connects those back the other way. So when you connect a keyboard to a key group, it will make apart from doing the forward connections, it will make the connections in reverse for the lighting channel. RPCs. RPCs are, I'm sure everybody knows what an RPC is. These are very, very simple RPCs. They take one string, an argument, and you get one string back, or an error string. That's it. They're not typed in any way. We tend to use other ways of marshalling data up into that string in order to send it. It's very easy to find most of these standard RPCs, but most of them are quite boring things. You can set the names, change the value, connect. The plumber the plumber's actually just a class which requires a database to work. It uses the database to decide what to connect, and then it uses RPCs underneath to actually make the connection. So it will tell some port, connect yourself to that guy. Verbs, again, we saw the verbs in the metadata. When the interpreter wants to invoke a verb, it uses the metadata to decide, who's going to do this verb, what arguments am I going to send, and then it uses an RPC in order to actually do the verb. Talker actions in the same way.
So the information to which agent I am connected stored in one of those two agents, or is it
Yep.
above?
If we go back, there's one here. This is the other end of the connection. When we make a connection, what actually happens is we tell him to connect to that guy. He will do that. He will also tell that guy that he's been connected so that this guy can keep that recording. that's used because if then you delete this person, he tells anybody connected to it to unconnect.
So essentially, an agent knows all succeeding agents. It's a linked list into one direction. Essentially, you go from one node to the other.
Yes, yes. Remember, agents are self-contained, and an agent knows who's connected because an agent is responsible for doing the connection. It uses the underlying protocols to actually do the connection. That's not magic. That's not done by EigenD. If you're connected to something, you use the networking facilities to monitor whatever it is you're listening to, and you listen to it. And then you do whatever you want to with the data as it changes. So that, yes, all that stuff is in the metadata. We have a Python module called PI, where most of this sort of stuff lives. You'll find PI database is the actual database class, which essentially you just kick it off and then it will sit there introspecting the system and you can ask it things. And it can call you back when stuff changes if necessary.
So, some specialized little question. So you could ask the database, is a Pico or an Alpha or Tau connected?
You could look for an agent called
Yeah, something
Pico.
like Alpha Manager, something like this. If the Alpha Manager is there properly, the Alphas. Okay.
Remember that behaviour is probably going to change a little shortly because we're hoping to make, or we're planning to make, the managers permanent, so that actually the instruments don't come and go in Workbench when instruments are plugged in.
No, it's
So that would probably become a status on an agent, wouldn't it, Jim, at that point, rather than a...
Yes.
I played around with the OSC agent, and the problem is, can I expect key 120 or can I not? I mean, it's like, do I have 18 keys or do I have...
No, that's a different question. You've got to, and this has changed a lot in 2.0. Is one of the big changes in 2.0. In 2.0, one of the streams coming out of a keyboard is the key number stream, right?
Mm-hmm.
Which, so when you press a key, you'll get something like a coordinate, 1, 1 or something like that. In fact, two sets of coordinates, physical and musical. There's another stream called the controller stream, which has a dictionary on it, which actually contains the geometry of the keyboard and its physical mapping.
No,
So-
it's more simple. It's like the OSC agent gives out the key number, and I wanted to take the key number and do something with it. I just need to know, do I have 120 or 18
How
keys?
many there are?
Yeah.
Yeah, just how many keys.
It's something the OSC agent you do with a port adding to it that actually allows you to see that dictionary with the keyboard geometry.
If we shot that out in another bit,
Yeah.
you'd have that.
Then something downstream of it would have enough information to work out
Yeah.
where it
Do remember, in normal case, there's going to be a key group or something in between the OSC agent, and that's likely to truncate the number of keys anyway. You know, you might have 13 or 27 keys, or they might be arranged in a hexagon or something like that.
All sorts of crazy stuff might have happened to them
Yeah.
on their way.
But still having something that you could ask about.
If we put the controller stream, which would be available to the OSC agent, onto the OSC messages,
Yeah.
you would have that
Yeah.
geometry. You'd have full geometry.
You have
information.
33 keys available or something
Yeah.
like this.
Yeah.
Yeah.
And that would be the way to do that, actually, is
Yeah.
just to put that controller information on. In the old days, we didn't do that.
You have to be careful about the assumptions that you make there, because as Jim said, users could put anything in front of that. So you can assume that 33 keys would be arranged in 2 columns.
Well, you get X, Y on the controller screen,
Right,
then
so-
you get a geometry, right?
They can totally be something
Yes, but they don't
different and come
necessarily
from
start from
somewhere
zero.
else, and the 33 could not mean what you think it means. It could be because it's a section of an alpha, not a section of a tau, and you.
Yeah, no, it's
Right.
just the question is, what is the highest key number coming out of this thing? Just really simple, not mapping,
Yeah.
nothing else.
Yeah.
It's just
It's-
what's the highest key number coming
Easy
out.
to add to the OSC agent. for
Yes,
everybody.
that is just an OSC agent change.
Yeah.
It's not
It's not a big deal.
anything in there. That's available to all things. Things like the scalars have to know because they do musical things depending on courses and stuff like that. So they need to know that stuff anyway. Anyway, the interpreter gives you some useful RPCs.
Sorry, Jim, can you stand a little bit?
Sorry. A good one is dump. Less useful now we have Workbench, actually. That used to be quite useful. I can say dump Pico keyboard 1 and it'll tell me all the connections going to it. again, part of the interpreter's database is what's connected to what at any
I've
time.
seen that before, because do you get the same behaviour if you're in the commander? If you, I think you have to talk to the interpreter and then say agent connect, and then you can go and look in the log file and that's
Yes,
in there.
yes, this is actually the same business. Still useful is identify. If I give it pico keyboard 1, it'll tell me the network address of that. This extra stuff, this part is actually the workspace. Each of these names have a kind of a workspace on the front of them. That's used for rigs. And something in a rig will have a different
Is that
workspace.
actually the index
Hmm?
now? Is that actually the index now?
No, it's the
It is, it's just because there's an index called main, and there's a
Yes,
workspace called main,
yes,
so they're not
yes.
the same.
no. No.
Okay.
In fact, the main index of that main workbench, you could say you could BLS main colon main, or if you've got a rig 1, for instance, will have an index name, a workspace of rig 1. So you could say BLS rig 1 colon main.
But the index name of rig 1 was rig 1 as well. In the list you showed before, there was an index called rig 1.
Oh, that's its name. That's its agent's name.
Ah, I
So
see.
yes, the rig 1. Remember, a rig actually has two agents, one inside and one outside.
One outside, yeah.
So a rig 1 will have main colon rig 1, which is the outside agent
Yeah.
in the normal. It'll also have rig 1 colon EigenD,
Yeah,
which is the
which is the
inside.
other side. Okay, cool.
Hence the insane name
Hence
for
the-
the gateway.
Yeah.
You're there now.
Now I see where you're going, right.
Why have I?
Name is always the canonical name, so I don't need hierarchies for this name.
Mm.
Okay.
You don't have to, it's not unique inside.
The hierarchy actually happens within the work within. Oh, I've lost. Oh, there we are. The hierarchy actually happens within that part. If you load a rig inside a rig, the workspace will be rig1.rig1 or rig1.rig2, and then the agent. The way that the underlying library works, generally most agents have a default context, which is a default workspace which they work in. Only some agents need to really worry about that, like the interpreter, which introspects everything, and the rigs themselves, which also are running agents in two
So
spaces.
the canonical name of an agent within a rig is not just, or to rephrase it, not the last part of the name is unique globally, but only the whole thing. So I can have, if I build a new scalar, it will be called
Scalar
rig
2.
1.scalar1.
Yeah, and if you put another scalar in that rig, it'll be rig 1, scalar 2. Yeah, there could be two scalar 1s, one inside the rig and one outside the rig, or in different rigs or something.
Because each rig is like an EigenD, which is on
Yeah.
index.
Yeah, it is. I mean, it's the same. I mean, if you look in the rig code, it's actually mostly just a piece of code out of EigenD.
There isn't actually any particular reason we can't do rigs inside the rigs either, is there? I think.
You can.
You can already.
Yeah.
Okay. No.
I presume these are just human readable form for understanding. They're not, you never actually refer to these things directly.
To refer to.
But you never use the string directly. It's not like you
No,
want to generate the string.
No.
Yeah.
No. It's just a network address, and it's like an IP address.
It's an IP,
So you use it when you use those command line tools.
Yeah,
basically.
so I'm going to say apart from
Yes,
that, but when
yes.
you're programming, you never use
Yes.
it. An agent would never refer to a named
No.
thing with a string.
So, looking at ports, we're going to look a bit more about port data. Again, we're looking at, we're going to look at pressure values coming out. So here, I'm actually holding down a whole bunch of keys on the Pico, right? So we're seeing a whole bunch of different streams. So I'm holding down these particular keys, 4, 15, 13. From a keyboard, it's coincidental, sort of, that the event ID is actually the linear key number. Back in 1.x days, that was the way you knew what key was being pressed. Turned out to be quite a bad idea. So now we have this separate screen which actually holds the key. The event ID could be anything, but it's actually quite useful. It's the same. It's something you could rely on. There's no reason that we would need to change it. So as you can see, it's coming out of this one port is a whole bunch of different streams, eight different streams in this case. And looking at on audio input, sorry, we have a 0 value on there with no event.
Can I just say something about what you just said? Just to warn about that. You could rely on that, but don't forget that the key stream is able to remap it. So if you're further down, you will still get the same event ID for a particular pressure event. So you get pressure going through.
Oh, will you? I thought because the key group used to remap the event IDs to the new key. Oh, does it not do it? Okay, forget that. You can't rely on that event ID.
I don't think it's a good thing.
Okay.
Can I check what you just said? Because this does affect something I was trying to do. You just said that there is a separate port for the actual key, the identity of the key you're pressing. Yes.
Yes.
So it will have an ID and a number.
Yes, it'll have the same. So
It'll say the same event ID. It just might happen to be like ID 16. You might just happen to have the value 16.
When we skip forward, we'll
Oh,
see.
there's an example. Okay. Perfect.
Right. So we've talked about, because state variables can have both this slow and fast value, ports kind of inherit some of the same properties, but we do restrict it just for sanity's sake.
So this data is also currently sent as a string from agent to agent?
No, the value of a state variable, actually, we use an internal data type which can have a bunch of different types. So we have things like dictionaries, tuples, strings, longs, floats, buffers, all sorts of different stuff. So a numeric value is generally a numeric, centers a numeric value.
So that would come as an extra overhead if we move to OSC, the serialization into a string.
No, OSC has data types as well.
It has? Okay, good.
Don't think it has dictionaries, unfortunately, which we started to use quite heavily.
But we could add those in.
Yeah.
Such early days of OSC that at the moment, maybe a little liberty to.
I don't know very much about OSC.
Yeah.
It's very primitive. I think it's very primitive. I think. Not much to say about that, really. So it could do with dictionary values. It would be fantastic to have them. So if we added them, I'm sure everybody would be very happy if we then published it. So.
Except for the people who've already got OSC implementations that don't want dictionaries. But OSC does have a way of defining extension data types, I know. So if it doesn't, you could have them.
But you're essentially using dictionaries as polyvalues as well. Sort of using them.
Anyway, so we've got this sort of these fast values and slow values. The slow values are persistent, the fast values are not. Now, a port can have both, but it's you get too insane if you have both. So in general, a lot of ports are just slow. They don't have fast values. They're things like, they're just parameters. Just things like the name of something or what sample I got. They're just persistent state. Or when you get the interesting thing is when you get into ports that deal with fast data flows. So if a port is an output like this one, which can carry these whole bunch of fast data flows, then the slow value, it doesn't really have a slow value. Slow value, there may be a null value in there, but it doesn't mean anything. It's not used by anything. And that's for outputs. Now, if something is an input, and this is where it gets tricky. Remember, inputs don't appear on here. An input is done because the port is listening to something else and doing something with the data. The only visible thing you can see is the slow value. It's what that slow value is used for. If it's used for anything, it's actually used as a default value for that port. So if the port is connected to something, in general, that value may be completely ignored. If you have something connected to a volume, and then you go and use stage, which wiggles the slow value up and down, that wiggle will not do anything at all in general, because the port is connected to something and it's using whatever it's connected to drive that value. It's not mixed. Certain ports might use it as default. So if the agent is doing something and it's got a signal on a volume, but the signal doesn't apply to anything it's doing, it might use the slow value as the default.
So basically signal trumps slow values.
Yep.
Yeah.
We'd like to have the mix, but that's really hairy. And we've had a little go at that a couple of times, and
Sounds like a little agent in its own right.
Yeah, it's because it's very domain specific.
it's very hard to
What
make that
does
work.
mixing two dictionaries mean?
Exactly, it's a difficult problem.
So if I connect, if I make a connection to a port that as a default, this default is not used anymore, even so outputting agent is not sending anything, or is it has it to send something.
Well, remember that the way an input is used on a connection depends on the agent, really. But yes, if the output has something, that input may not affect the output in any way if the port is connected.
So is it, for instance, even technically impossible that let's say an integer, I want to have the octave for a scalar, for instance, and I have an agent that outputs an integer. And if I connect the octave to this new agent, and is it technically possible that this agent just does not output any integer? Or
well, no, it should use whatever you're sending it as the octave. Yes.
So is there also a default for an output if the agent just doesn't?
Well, no, because remember this is a model where things listen rather than things send, so it's not a push model. So when you make that connection, it will pick up the value of that output automatically. So if you make the connection, you will have a valid value on the input.
If your agent uses that value, then it will appear on the output. If it doesn't, I mean, it's up to the agent what it does with it.
Yeah.
It can do anything it likes.
So you're saying?
But no, I think I understand the question here is whether or not you might end up with a situation where the default value is ignored and no value has been set inside the agent.
Yeah.
That won't happen because it will always go and pick up the starting value of the other agent, won't it? It will go and query. You know, it's a listening model. It goes and gets the value that's on the output of the other agent. It's not waiting for a data change or a push. There's no push. It's all listen. It's no push.
Don't think of MIDI packets. When we make a connection here, we've seen these sort of bundles. There are events possibly on there. Think of it as when you make a connection, or when I press a key, an event is created. The event is like a wire that gets threaded through wherever it's going. It has a current value. When I let go of the key, the event disappears again. But an event always has a value on it. So it's more like a virtual circuit model than a
my agent only starts calculating output events itself as soon as it got one event for every input it's connected to.
That's the way most agents work, yes. It doesn't have to be the case, but that's the usual case, yes. You usually process events. An event comes in, an event goes out. With the C filter model we talk about is a framework that makes that assumption. Incoming event equals outgoing event with something happening in between. One-to-one all the time, and that's why it's a nice simple model. But that's the only, we've had attempts at making different frameworks, that's the only one that survived really so far.
So if I understood it right, my scalar agent just would do nothing as long as, or until the octave value comes from the subordinate input.
Yes.
So it's a lazy input.
But actually, it wouldn't do anything on an octave input because there's nothing to do it to. In general, the scalar is quiescent until an actual key event comes in, and then it will use the octave as part of the transformation of the key into a frequency.
It's not very meaningful with a scalar to do anything with an octave input on its own. It has to have actual data to apply a scalar.
Does things to keys.
So
even if I play various keys, as long as the octave value did not come, does it queue all the inputs then, or does it just revert, throw them away until I have an input?
It's not that the behaviour of the agent is that it says, right, I've got some key information coming in now, what should my octave be?
Yeah.
And it goes and looks, it's almost looking the other way.
We're jumping
It's
ahead again,
reading
so let's let
this listening model, isn't it?
Yes.
And if you've got something connected upstream of it that's going to have a value it can inspect,
Mm-hmm.
then it will get it from there.
Could I make
then it goes to this default value.
Yeah, let's shelve that because you might get answered later.
I'm just going to make a suggestion here. We are now running well behind schedule. Kev, are you happy to do your talk after lunch? Should we do that instead and have a talk after lunch rather than start straight in on programmes? Is everybody okay with that?
Yeah.
Then it'll be a nice shift for change and we can chill a little bit about Jim's talk then, because otherwise we're going to have to throw him out. And
Yeah.
his lunch is in
Maybe
45
anything
minutes.
else that looks like it would take 20 minutes to discuss, we could do over lunch.
Yeah. We're actually getting.
But I don't think I get my stuff done in 45 minutes.
No, I don't think so.
It's scheduled for 1:30 today.
So 1:30 lunch is it? Yeah, but even so, I think we're
Pushing it.
pushing it. Yeah, it's a little bit more relaxed and you know, we can all snooze while it's after lunch.
Great, that's a good time to watch a demo.
Yeah.
I might snooze.
Just
Wake me up when that happens. We'll throw things.
Okay. Anyway, so any port actually has essentially this slow static value and anything that it's connected to currently. What actually it does with those values tends to be quite specific to the agent. There are agents that work in quite different ways in that respect. And so what happens in the actual code, atom is our class for report. We use it for leaves and nodes, and a report really is a leaf atom. And all the data handling part, the atom class itself just deals with boring things like metadata and stuff like that, and children. The actual data handling part comes from a policy. So, and you can easily write your own policies, and there are lots of different data policies that do some quite weird and wonderful things, with their data flow. I'm showing some quite boring ones here. This policy, the default policy, takes a callable, some sort of callable object. Here it's just a method, a Python method. So here we have something called the key row, and when you set it, it'll call that functor, and that's a general static configuration kind of port, not dealing with anything fast data. If you connect fast data to it, the normal policy, it will actually decimate the incoming fast data, step it down into the slow thread from where it gets it in the fast thread, and end up calling that functor. If you connect audio to that, you are going to get a system that crawls because it's going to be calling Python a lot. If you imagine audio coming in at, the audio will start off as ISO, it will be an ISO, but it'll still be calling it, at 100 hertz or something like that. These policies, that's the general one for slow stuff. This is one that has a fast value on its output, and we use that so things like trigger values. It's not really a proper performance output. It's just a fast value. So there are lots of these policies, and you can choose whatever you want, or you can roll your own. You won't need to, probably, because I think we have most of them covered now.
They all live in the same class.
And they're actually quite simple things to implement. Stepping away from that, back to tie up some loose ends. We've talked about a lot of this. The setup manager. The setup manager looks at state variables. The state file is essentially a record of the state variables, and it tracks it continuously. And when you save the setup, it basically takes a snapshot of what it's got at that time. That's the setup. If it's not in one of these slow values, like either in the metadata of a port or the value of a port, it's not going to be saved. When the setup manager wants to load a setup back in, it goes and looks at the running system, looks at what it's got, and builds a diff. And it builds a diff, encodes it in a string, and sends it as an RPC to each agent. Lots of side effects can happen. When you initially load a setup, the only agent that exists is EigenD. The setup manager looks at the diff between the EigenD setup and what it has, sends that. The side effect of that is actually that 300 other agents get created. When those come up, the setup manager then builds the diffs for each one, sends the diff through, and that happens. That's the way setup works. Setup's not built really. The setup manager is inside EigenD, but it's actually logically a separate agent, and it's not coupled with EigenD at all. The setup manager inside one EigenD could be managing another EigenD if we wanted to do it that way. Because of side effects, it's not quite a simple process. So there are, when it's building a diff for an agent, for instance, there are whole trees that may appear as a side effect of something else. You have to tag that for the setup manager so that the setup manager knows to just send the whole tree instead of the diff. Normally, things that don't exist are ignored by the setup manager, so those things would get ignored otherwise. The tags make them.
So the simplest thing is, if you're writing an agent just to mark it, just to send me the whole thing and almost take a panic approach, I suppose. You
could do that if you wanted, but you won't generally, as long as you're careful, reasonably careful, you don't have to worry about setup. It just happens for you as a side effect. Talk about side effects there. FX channels. I mean, but the mixer has send effects, but you can create channels dynamically, and that's part of the setup. So generally, the setup manager, it'll have the setup for a channel, but it won't have the effects ports in it on the initial system because they haven't been created yet. So once they get created, as a side effect of loading the setup, you get the effects channels values. So those are tagged as being this sort of side effecty thing to make sure they get put in even though the state manager can't see them. The only real gotcha with this is that if you think of a connection, you've got set up at both ends. There's that list of slaves, list of connections. Making the connection builds that thing. When you're loading the setup in, it's not the same as creating a connection. You're restoring a connection. Quite often, when I make a connection, I'm doing both ends. When I'm reloading a setup, I'm only doing one end of it. You need to be careful about cause and effect here. But again, mostly it doesn't happen. It's only things that cross channels that do that. But sometimes it's important to differentiate between loading a setup and creating a new object.
The goblins are unhappy, Jim.
Yeah. When you code, you'll soon. This becomes fairly obvious that this kind of thing is happening. You know.
So I think we might have a minor plumbing problem there. Actually.
Again, what's in the setup is what's saved. There are some things that we don't keep up to date, like VSTs, AUs. Their state is quite big. As they change, we don't continuously update the state variable because it's just a mess. So there are actually hooks. When the setup manager is working, before it loads, it goes and RPCs everything saying a load is going to happen. That lets the agent get its state variables current so that the diff can then work. And pre-save again, it's make sure you're up to date so I can save you. I think it's only things like rigs and AUs that use this mechanism really at the moment.
Well, right. I mean, is saving and loading setup pretty much the only thing that's transactional like that, which sort of says pre-prepared.
Yes.
Now we're doing something. Now we're done.
Yes. Most other things are pretty much one shot.
Yeah.
Doing a verb, you just do the verb.
Yeah. There's nothing else transactional.
Yeah. All right. Fast data. This is where what you're going to be dealing with mostly. So fast data, slow data is it's quite you send a thing, you get a virtual function saying data changed. Here's your piece of data. Fast data happens too much to do this sort of stuff. So the fundamental thing is actually a data queue, which is a ring buffer of a fixed size, and actually we generally pass ring buffers around. So if I'm a keyboard, when I hit a key, it creates a new ring buffer for this event. The ring buffer gets sent downstream through all the connections, and then as data comes in, 2,000 times a second, I'm putting it into the ring buffers. It doesn't get sent explicitly down the connections. The ring buffer's sent, and the data goes into the ring buffer. You can subscribe to a ring buffer to get notifications of data coming in. We try not to do that because it's not that efficient. In general, things happen in clock ticks, and you poll your ring buffers to see where they are at any given time.
What happens if I send a message to two agents that come after me? Is it essentially read only for both of them? Or is it
yes, only the person who creates a ring buffer can put data in it. If I have an agent that, suppose we have a keyboard, something that transforms the data, he's creating a new ring buffer. So he's on a clock tick or as a push, he's reading that data, generating new data and putting it into a different ring buffer. And he sent that new buffer downstream instead. Ports have multiple channels, but each channel inside a port has the same kind of data on it. The pressure port from a keyboard has pressure values on it. The yaw port has the yaw values. You don't have a port that has pressure and yaw. The same thing. It's all the same stuff. Generally, you have a port called like audio is sent with a different port for each audio channel. So it's all the values are left-hand side channels. If you've got a polyphonic instrument that's running more than one keys, it's going to be generating more than one left audio channel, more than one right audio channel. That's what. For instance, the summer agent goes in there and will mix those all down into one value for each one. But each stream inside a port is meant to be the same thing. Right, getting into events. So, events have IDs. Again, it's a dotted number, 1.3, 4.7, 1, something like that. We saw some simple ones before. So the ID, it's unique to a port at a given time. You can't have 2 events with the same ID on the same port. And that's as restrictive as it gets at the moment. We might make that stronger in the future. There might be different events with the same ID on different ports. This is what we're getting to before. So if you've got pressure rolling yaw signals coming out the keyboard, if I hit key 1, I'll get the same event ID coming out on all those ports with the different things. That's how I know that they're related to each other, because they have the same event ID. So just to looking at the output of a Pico, so I'm holding down keys 1 and 3. On the pressure output, see I have 2 events. On each one of them, I have 2 events. I'm also wiggling the strip controller, and I've got 1 event coming out of that. There's only 1 strip controller, so you can only generate 1 event at a time.
So what we're seeing there is, so ID1, ID3 in your top row, for example, what's coming out of BCAT is a snapshot of pressure output.
That's just the latest value.
Then you'll have a ring buffer somewhere which will have 0.4255 and then a whole stream of
other agents are getting this as a connection. BCAT here is just showing you the last value on the output there. Remember, there's always, even if an event isn't sending data at the time, as long as the event's going, there is the last value. Events always have a value. So that's why they're more like wires than like packets. So the dot is the empty event ID, the kind of root event ID, if you like, and that's what things like strip controllers use.
And the ID null is?
Null means there's no event. So that part of the subtree, there's no event on there. There's an event on there, but not on that one. In general, fast outputs, we tend to put them onto these sub-things. We don't use this node.
Right.
We use this node for slow data if it's applicable to that port. So we talked about this before a bit. Connections. When you connect something, remember agents are self-contained. When you connect to something, you're telling an agent to go off and listen to something and look at it and do something with the data. The connections aren't really a system primitive. And it's the policy that deals with connections. It actually implements the connection thing. It creates a class which goes off and introspects the other end and sucks the data in. Looking at some connections here. So we have a keyboard in output from the keyboard that's it's listening. This is the light input on a keyboard, and so it's listening to the light output on a key group. So this, in the metadata here, we have the master tag, which is a list of the things this is connected to. And this connection thing is actually, there are a whole bunch of parameters to the connection. The primary thing is what I'm connected to. At the other end of this connection, slave, this isn't used for anything. It's there for sort of informational purposes. When the connection's set up, this is set up at one end and that's set up at the other end. The only thing it's currently used for is if you go and delete this thing, it will go and tell all the masters that this has gone away and you should disconnect. It used to be done by the interpreter. That's now central. There's another one. This one's slightly different. Remember we talked about slow values and fast values. If I'm an input, remember I've got the slow value, which is my default value, and I've got my primary inputs. When I connect to something, sometimes I want to use it as a normal connection. Sometimes I want this connection to actually control the slow value. So you can connect to the slow value, or you can feed in fast values. An example of this is actually stage widgets end up connecting to the slow value because they're controlling that slow value. That's just a parameter to the connection. You can spot it in here because it's a control model connection. So connections are really quite simple. Connections are not fundamental. They're built in. It's mostly Python code in the PI, in the policy. When you look at data, if you look at data policies, you'll see most of them inherit from a class called connectable policy, and the connection gubbins is all in there.